Hello everyone, welcome to the live video. Let's wait a couple more seconds for everyone to join and then we'll begin the lecture. I think 2 minutes have passed, so everybody must have joined. So let's begin. Welcome to this lecture. In this video, we're going to be covering, not video, in this live video, we're going to be covering the topic of counters in Python. And I seriously hope that you've seen my previous videos of dictionaries, because counter topic covers few concepts of dictionaries. But even of those who haven't watched that video, no need to worry. We'll cover that in, not the entire part, but we'll cover some basics in this live lecture. So you won't feel lost. Okay, so no need to worry. And let's begin. Okay, so first let us discuss what does the term counter actually mean. So if we bisect the word counter, so we'll see that it is coming from the root count, right? So count, I don't need to explain what count is, but in a very layman sense, 7 apples, 10 kilometers, 10 minutes, these are some things that you can count, right? So counter, we know now, that has something to do with count. Okay, so imagine you've been given a programming assignment, and you have a data structure of a list, and let's say you have many different items in that list. Let's say 1 1 1 and 3 2 4 4 5 and 6, right? So now you want to know what all different unique values are present in this list and what is their count, right? So as you can see, if we try to see this list, you'll see that okay, one unique element we are encountering for the first time, right? And then one, we've already seen one, right? So this is the second one. Another one makes it the third one, and then we have 3. 3 is a unique element that we haven't seen up till now, so we write 3 here. Next is 2, so only one occurrence of 3 so far, right? So now 2, also a unique element, write it here, 1. Now 4, a unique element, 1 occurrence. Another 4 plus 1, so 2 occurrences. Then 5, 1 occurrence, and then 6, also 1 occurrence. We write it here, right? So this list can be represented as, in a much simpler sense, that 1 is occurring 3 times. If we do not consider the order of the list important, we can explain it that okay, the number 1 is occurring 3 times, 3 is occurring once, 2 also occurring once, 4 occurring twice, 5 and 6 both occurring also once, right? But now you're wondering that this is like pretty boring stuff, right? How exactly is it going to benefit in our real life, or maybe how will we use this counter in a real life? So imagine you're in retail, right? You're employed in the retail section of any store, and let's say Walmart, right? And then you have to create a statement that how many fruits were sold in a particular day, right? So probably it will be something like 10 apples were sold, right? And then mangoes, let's say 15, kiwis 23, for example, and oranges, let's say 40 oranges were sold in that particular day, right? So now this seems something similar to what we just discussed, right? So if we name apple as 1 and mango as 2 and kiwi oranges as 3 and 4 respectively, so now you can see that 1 is occurring 10 times, 2 is occurring 15 times, 3 23 times, and 4 40 times, right? So we can write this as 1 is equal to 10, 2 is equal to 15. I mean, you get the idea, right? What does counter basically does. So we have to figure out how to create a program which will do this for us, right? So this entire process is known, this entire program would be known as a counter. So which can tell you how many times a particular element is present in a data structure, which is similar to a list, right? In this case, for the sake of simplicity, we are going to be covering only lists, right? So how many different items are present in a list, that is what a counter basically does. That is the definition of counter. Okay, so in before we proceed further, there are some basics of dictionary that I would like to cover, and I'll so dictionary is a data type in Python, and assuming that okay, I it is represented by the letters DICT. So dict is the dictionary data type in Python, and let's say I have a dictionary and it is represented by these curly brackets, right? So for those of you who don't know, dictionaries, let me just, yeah, so dictionaries, they store key value pairs, right? So inside these curly brackets, let's say we have a dictionary by the name of D, they store key value pairs, right? So key value pairs, what are key value pairs, what is a key, what is a value? Key value pairs just goes by the definition. You can just say that A is mapped to B, right, inside these curly brackets, and if many such elements are present, it becomes a dictionary, right? So if I have to create a data structure where I have to store the information, where I have to store the sales information, apples equal to 10, oranges equal to 15, right? So I will, this is a comma, so I will use a dictionary, right? So the apples would be the key, and this integer value, which in this case is an integer but can be any other value also, is a value, right? So this one particular entry is known as a key value pair. So this is one key value pair, this is another key value pair. Okay, so this is what a dictionary basically does. So now you have a dictionary, and apples is mapped to 10, so 10 apples were sold, and then maybe oranges, 15 oranges were sold. So now this is a dictionary. So if I print type of dictionary, so type function is used to define the data type of a particular variable. So print type of dictionary, class dict, it belongs to the dictionary data type, which is very obvious, as we've defined a dictionary. So now if I print this dictionary, this is going to give me the same values I've just inputted. Now if I have to access a particular key of the dictionary, right? So if I want to access the apples key, so this is enclosed within square brackets. So within square brackets, I'll enter which key I want to access, and if I print, so then 10 will be my response, will be printed out. So if I want to access the keys of oranges, it will print out 15. Now the question is, what if I try to access a key that is not present, right? So what if I try to access the term banana? So this gives me a key error banana, which is supposed to mean that the key banana that you're trying to access is not present in this dictionary. Okay, cool. Now what if we are in a situation where we are given a dictionary, right? We are given a dictionary, but we don't know if a particular key is present or not, right? So how do you check it? You use the inPresent function in Python, and if apples in dictionary print present, it prints present, apples key is present in our dictionary, right? Now if you want to access an element but you're not sure it is there, right? So just like in this case, you're trying to access banana, but it gives you an error that banana is not present in the dictionary. So now you want to know if it is present or not, but you don't want an error, right? Because that will throw off the whole program. Nobody wants an error in their code. So how exactly do you get around that? You use the get function. So dictionary dot get, and I'll pass the term banana in there. So if it is not present, it's going to return a none value, right? So it's not going to throw an error, it's not going to return you anything, right? So it's just going to tell you that whatever you're trying to access, it's not there, right? If I try to access apples, it will tell me apples is mapped to the value 10, right? So 10 apples were sold. But if I try to access banana, sorry, not available. Now if I want that, just don't return me none, I want you to return 0 if the value is not present in the dictionary. So I'll pass in 0 along with this function, and it will return me 0, that 0 bananas were sold that day. I can write 1 and it will return me 1. I can write anything that I want it to return. Okay, so this is very basic dictionaries that I'm trying to explain you for the people who don't know what dictionaries are, because later on, as we progress in this video, we're going to be using these dictionary functions in counter. Okay, so I just want you to get the basic feel of how a dictionary works and what exactly it is, so that you don't feel confused when we move to some advanced topics, right? So now we know the get function, and right, so I think the basics of dictionary is done. So now let us try to create a counter, right? So we have let's say a list, right? And let's take the previous list in example, like this one, the first one, right? So we have this list with us, and I want something like this, right? I want the final result to be something like this, that it tells me that okay, 1 is present this many times, 3 is present this many times, etc., right? So basically what I expect out of a counter is that in a dictionary, if we have a dictionary, so it should, in a row and column format or a key value format, return me element, and map to the element is number of occurrences of that particular element, right? This is what the basic goal of a counter is. This is what we're trying to establish, right? So this is our problem statement. This is what we want to solve. We'll solve through one way, we'll solve through 5 different ways, right? So don't worry, we'll get to that. But first, okay, I have the list, and that is 1 comma 1 comma 1. Let's put in another one, right? So 3 2 4 4 5 6, pretty similar to the one. And let us create an empty counter. Okay, we'll fill in the counter later on. So now for I in list, we are going to iterate through the list, and we just discussed that if you have this list one, let me just right. So in this list, what you want is to iterate through every element, right? If the element is new, you want its counter to be 0 or 1, depending on how we are going to proceed with the statement. And then if the element is not new, if it is already present, then you increase its count by 1. That, okay, we have seen it before, we have counted how many times the element was present, and now we have seen it again, so you increase the count by 1, right? So if you see the element for the first time, we'll just remove this 0. If you see the element for the first time, you set its count to 1. Okay, the element is being encountered by us, we see it for the first time, so its count is 1. Now we see it for the second time, we increase the count by +1. Okay, so this is the basic goal that we are trying to achieve. So for I in list, if I is present in the counter, right? If I is already present in the counter, then we are going to increase the count of that particular element by 1. Else, if it is not present, you set its count to 1. Okay, this is what we're trying to establish. If we have already encountered the element, you increase its count. If we are encountering it for the first time, you set its count to 1. Let's see what is the code going to return us. So it's going to return 1 is present 4 times, 3 is present once, 2 is present also once, 4 is present 2 times, 5 is present once, and 6 is also present once. Okay, so we've made a very rudimentary form of a counter. We've understood how do counters function, and I hope you have a basic hang of what the term counter really means. Okay, now that you know what we're trying to establish and what is the final goal of the project, let's just find different ways of doing, because this seems very elaborate. You're checking, and then you're checking for every element, and then the code that you're using here is pretty rudimentary. So let's try something more advanced, right? So we've just used the learned to use the get function. I told you some basics about it, so let's try and do it through the get function, right? So imagine we have, let me just copy this code. Now imagine you have the exact same list and the very same counter, right? So for I in list, this remains same. Now instead of putting in two if and else statement, we are going to use the get statement. So counter of I, let me just write the code and then I'll explain it to you, right? So what does this code mean? Don't worry, I'll tell you exactly what it means. So now counter of I don't think I need to explain you what this part is doing. This is making a call to the ith element, right? So the ith element is a key in the counter dictionary. You're making a call to its value. Now counter dot get I comma 0. What exactly does this mean? So now imagine that you're trying to access the I element, right? So the I element, let's say, is being encountered for the first time, right? So if it is being encountered for the first time, then it will not be present in the counter dictionary that we have made, right? So let's see at the very first index only. number 1 is being encountered for the first time, so it is not present in the counter dictionary, right? So if I just write counter of I, it should, if I try to print counter of I, it will give me an error that sorry, that the key you're trying to access is not present in the dictionary, right? So how do you go about that? So we've just seen that a way around that is using the get function. That it will not throw you in an error, it will return you whatever you want to return, right? So counter dot get I of 0. So if I is being encountered for the very first time, instead of throwing an error, you return the value 0. This is very similar to this statement. Instead of 0, I think we should write 1 here. Yes, we should write 1 here. That's a mistake on my part. So let me just change this up. Yeah, so now that we've written counter dot get I comma 1, so now what this will do is that if I is not present, it will return 1, right? This is very similar to this statement, that if not in counter, you print I is 1, right? And then you use plus 1, so you increase that by 1. We'll just stick to 0 here only. I'm sorry, this may sound a bit confusing, but the main goal here is that if it is not present, we want it to return 0, and then we'll increase it by 1. If it is present, it will give you the count and then increase it by 1. Okay, I'll run this code and then we'll see how it performs, and it performs very similar to the one that we have here. So counter dot get I of 0. If we would not have been using this plus 1, then we would have used 1, but we wanted to increase the count also if it has already seen it, so hence we use 0 and not 1. Okay, so this entire code is similar to this code, other than the fact that this is much shorter, right? So it is much more concise and it is easy to read also. Same output in both the scenarios, as you can see, 1, 4, 3, 1, 3 is occurring once, 2 is also occurring once, 4 occurring twice, 5 and 6 both occurring once. So I hope you get a basic idea of how to deal with the counter problem using dictionaries. Okay, cool. Now we're going to another topic, that is using a library called as collections. Collections is an inbuilt Python library that gives heightened dictionary functions. So it provides much more usage in the dictionary data type area, right? So we're not going to cover the entire library. That's going to be very, very hectic. We're just going to use two different functions. So number 1 would be using the default dict that collections has to offer. What is default dict and how is it going to function? No need to worry, I'll tell it to you. So I've just written 2 lines of code that probably some of you might not get, some of you may even get, but don't worry, I'll explain it to you, right? So what is a default dictionary? What does this term mean? You're probably not going to believe me when I tell you, but it is a dictionary, right? So you might ask me, if it is a dictionary, then why do we need this dictionary and not the one that we've used here, like in the counter variable? Why not this, or why this? What is the difference between these two dictionaries? So in most scenarios, both these dictionaries actually behave very similar to each other. So what's the difference between these two dictionaries? The difference between these two dictionaries is that if I am trying to access an element that is not present in a default dictionary, it would not throw me an error, right? So basically no error if key not present. But do we really need that? Because we've just learned the get function, we've seen that we can put an if statement also to get around that. So how exactly is this going to benefit us? So let's say I define a default dictionary right here, like I've just done, and then the value that I defined it, or the data type that I defined with, the default data type is an integer, right? So what basically happens is that in a default dictionary, after I've specified the data type, which is integer in this scenario, the dictionary, which is, let's say, defined by the count variable, would be filled by random keys, right? So random keys k1, k2, k3, and all of them would be mapped to an integer that would be 0, right? What are the random keys? Can we access them? Can we know what is in them? No, it's not that complicated as you're thinking it to be. It's basically all the values in these dictionaries will be 0 unless specified. How exactly does that function? Don't worry, I'll tell it to you. So now in this new counter variable, I've defined a default dictionary with the data type integer, right? So now the dictionary, if I try to figure out what's the data type, it's a default dictionary with integer as its default data type. Now if I try to access a key, let's say apples, right? Apples is definitely not present in the dictionary because I've just defined it, and the dictionary is empty. Nothing is present in the dictionary. So if I try to access a particular key, that is apples, so if I try counter of apples, it'll give me 0, right? It should actually throw me an error if I was using a normal dictionary, but in this scenario I have defined the default data type, so if I try to access a key that is not present, it will give me 0. This is very similar to if, let's say, there is a dictionary called count, empty dictionary, and then I print count dot get apples comma 0. I don't need to use the print function, we can do without it. Oh, sorry, this needs to be done this way. So count dot get apples is 0, also returns me 0, right? So rather than using the get function always, I can just use a default dictionary and I won't have to use the get function again. If it's present by default, it'll give me a value of 0, right? So counter of a key in a default dictionary, if the key is not present, is similar to using the function get with default value to be 0. Okay, so these two lines of codes is similar to these two lines of code, right? So I hope now you know what is the difference between a default dictionary and a normal dictionary. So now that we know about a default dictionary, let's try to establish a counter. So we'll use the same basic list to test our counter, and for I in list, that is a constant now in the past few lines of code we've written. So counter of I plus equals to 1. What does this code mean? Let's first see if it actually works, and if it does, then I'll tell you. So you'll see the default dictionary that we have. 1 occurs 4 times, 3 occurs 1 time, 2 occurs once, 4 occurs twice, 5 and 6 both occur once. What is this code? How does it function? Don't worry, We'll get to that. So counter of I plus equal to 1, just one line and we have our counter ready. What does it mean? So imagine the index is here, right? We're trying to access 1. Your counter right now is an empty dictionary, right? It is an empty default dictionary and you encounter the element 1 for the very first time. So for I in list, counter of I, right? Counter of I. So I is 1. So basically it means counter of 1. Now 1 does not exist in the counter. We've established that because it's the first element that we're trying to check, right? So 1 does not exist in the counter, and we've just seen if an element is not present in the counter which is a default dictionary with default data type of integer, it's going to return us 0, right? So counter of 1 is equal to 0, and then the code says plus equals to 1. So plus equals to 1 means add 1 to this value. So now the counter of 1 that was previously 0 when we started the for loop is now going to be counter of 1 would equal to 1. Okay, similarly you access 3 here, which is a new element. So counter of 3, which has not been encountered so far, would be 0, right? And then plus equals to 1, you add 1 to this value, and then counter of 3 becomes 1. Okay, I hope you get the picture now. So now we have, let's see how many different ways we have to create a counter. We have this default dictionary, the get function, and the basic if and else loops to create a counter. So we have 3 different ways to create a counter. Okay, that's quite a lot of ways. Let's do another one. So now this might come as a disappointment to you, but collections library also offers an inbuilt counter function, so you don't have to write all this code again and again. I know this is disappointing that I've been teaching you counter and there's a simple function for that, but I think it's important to know the functions before just using them in a shorthand method. So if I define count is, let's just use the same basic list for our testing purposes, and count is counter of list, and if I print count, it's going to give me 1 is present 4 times, 4 is present twice, 3, 2, 5 and 6 all are present only once. So the counter function basically just does everything that we've been trying to achieve so far, right? But the counter function also offers a couple of new details, or basically new functions that probably would have been more difficult in our previous approaches to the problem. What are they? So number 1 would be that you can define a counter without actually having to run it through a list. So what is that? So let's say A is equal to 4, B is equal to 7, and C is equal to 9. And if I print count, keyword can be an expression. Okay, let me just remove the strings. I think I've made a mistake here. Yeah, so I did not have to write the I did not have to specify that what I am writing is a string, so that was a mistake on my part. And now see, this is a counter that we've created. Okay, so now this is very similar to the data type we have here. Why do we need to create a counter if we have a list and we can just do it manually? again we'll move back to the retail problem, right? So you're in retail, you're in charge of sales, and you have to create a whole account of whatever was sold in a particular day. So this would probably seem fun to you. So Monday sales, let's say, would be a counter of apple 10 apples sold, 15 kiwis sold, and 20 oranges sold, right? So now you have yourself a data type that tells you that okay, these many fruits were sold on Monday. Okay, now you basically want something that updates the counter, right? You want to update it every week, and then you want to store it in one variable. You don't want to create a counter and then add it, the whole fiasco. You don't want to do that. You want to just update it, right? So let's just change this into sales so far, right? This variable is sales so far. So Monday sales are another counter variable, and here on Monday, let's say people buy less number of apples, only 5 apples were sold. People are busy, they could not come to the supermarket, everyone's got work to do. And the kiwis were sold in an excess. Don't ask me for a reason, I don't know why. They were just sold more. And oranges were, let's say, sold the same amount, right? So if I want to update the sale so far function, so far we've had a sale of 10 apples, 15 kiwis, and 20 oranges. On Monday, another 5 apples were sold, 20 kiwis, and 20 oranges were sold. So if I have to, check for the sales that have been done so far, it would be apples sold would be 10 plus 5, that is 15. Kiwi sold would be 15 plus 20, that is 35. And oranges sold would be 20 plus 20, that is 40, right? So now I want my sales so far variable to actually show me the total of 15 apples, 35 kiwis, and 40 oranges have been sold, right? This is my final output that I want. How do I achieve it? I'll use sales so far, and then I'll use the update function, and in the update function I'll pass in Monday sales. And if I print sales so far now, you'll see I get 40 oranges, 35 kiwis, and 15 apples, exactly the way I wanted, right? Now let's see a different thing happens here. Let's say 10 bananas were also sold, which were not present in sales so far. Now how is the update going to function? How is the update function going to work out? It is just going to add the bananas variable exactly in the sales so far variable. So if I run this code again and then I print sales so far, you'll see that I get 10 bananas right here, just exactly how I wanted. Okay, so now this is the update function. The update function does not necessarily need to have a counter that needs to be passed. Okay, you can also pass a dictionary here, right? So instead of let's say a counter, we have a dictionary. In a dictionary you would have to pass the strings. You would have to specify that whatever you're referring is a string. So if you try and this is your Monday sales function, which is not a counter object, it is a dictionary object. and now you try to pass this in the sales so far function. Invalid oh sorry, you do not have to use an equal to sign in a dictionary, I almost forgot. So yeah, you run this code, and if I print sales so far, it'll give me the exact same result. Okay, I hope you're clear with the update function. Just one more thing that we need to discuss. So now let's say you have the final counter here, right? Let me just yeah, so this is our final counter that we have, and now you have an unordered collection basically, right? So now your manager tells you to tell them what was the most sold fruit, right? Which fruit has the maximum amount of sales in these many days, right? So we have a function for that as well, and that is known as most common function. So sales so far dot most common, and in most common I have to type in how many numbers of most or the maximum value I want. So if I type in 1, so this will just give me the most common value, first most common value out of the lot. So oranges, 40 oranges were the maximum sale of any fruit that has been recorded by the store. Now if I ask the function to give me the top 2, so it will be 40 oranges and 35 kiwis that we have. Okay, similarly 3 and 4, so they don't have 34 values. So 4 values would return us the 4 most common values present in the counter object, right? And if I don't pass in any value, it will just sort the list based on the values, right? If I do not pass any value, it will sort this list that I have into a descending order, right? As you can see here, the list is unordered. Apple, it is basically based on how the input was made, but in this scenario the list is ordered on the basis of the value that we have. So let's do a quick recap of what all we've learned today. So we learned a couple of basic dictionary functions, what a dictionary is, and the get function in dictionary. Then we were able to learn how to create a counter by using if-else statements and using a basic dictionary. Then we learned how to create a counter by using the get function of a dictionary. Then we also learned how to use the default dictionary function and the, of course, counter function, which is the standard procedure which is used in coding platforms, and basically it's a tedious task to write a counter function every time you have to find the count. So you would just use the counter function from collections, and we've learned how to do that. We can find the most common values also. So I think you have a basic overview of how the counter function works, and that'll be all for today's classroom. And if you have any doubts, please post them in the comments. I'll try to clarify your doubts as much as I can, and maybe we can even take up some of the doubts in the next lecture. And keep learning. Please subscribe to the channel, and I'll see you guys in the next lecture. Thank you.